Hello and welcome to yet another video where we are going to be talking about Java. Last time we talked about polymorphism and inheritance, so if you do not have the knowledge about it and this is the first video that you are seeing, then please go ahead to the playlist in the description that is then going to take you to the beginning, or if it's the first video that you see at all, this video is a part of a larger course about Java that is available for free. And why is it for free? Because I used to be a self-learner just like you, and for 5 years already I'm within the programming world, where first I was a Java software engineer and right now I'm a product manager handling 2 teams. With that being said, let's dive into the topic at hand, namely exceptions. So exceptions is actually something that happens if there is something wrong with the code, and if an exception happens and it's not handled properly, and we're going to be talking about how to handle exceptions properly in this video, then we'll run into an issue that will stop the working of a program. So let's showcase this by using a very, let's say, silly example, where we know that if we start with I at 0, then at one point in time, or rather in the beginning, I'm gonna divide 0 by 0. Let's check how it behaves. So yeah, I've got an exception in thread main Java, arithmetic exception, division by 0 at this particular point. So what you see here in the red is called an exception stack trace. So this is the way for Java to tell us what has went wrong and how to fix it. So in order to fix it, we just need to fix the division by 0. But of course, this is the simple part. But what happened here is an unchecked exception was called. What are the exceptions? There are 2 types. There are checked exceptions and unchecked exceptions. The unchecked exceptions are something that is way more dangerous because, as you can see, I can create the code and run it without the need of actually handling the exception. And if the exception happens, then I run into arithmetic exception in this instance and my code breaks. So very annoying. Another example of that would be string test equals null, and let's say I want to print out test.length. So here it will allow me to do so. I have a string test that is equal to null, but I want to call a method upon it. What will happen is I will get null pointer exception, meaning I cannot invoke string.length because test is null. So very descriptive information, and once again it's an unchecked exception. So those are the more dangerous ones, but of course there are the checked exceptions and how actually Java will behave whenever we have a checked exception. For this demonstration, I'm going to be using file class within Java. This is a class that we will use in the next video to actually operate on files when we know how to handle exceptions, but just for the sake of this demonstration, I will create a new file object that is going to be pointing to the path of test.txt, and then we want to create new file. And here, as you can see, it's in the red. And I got information that I've got an unhandled exception for this particular file, rather for this particular method. So what I need to do before Java will allow me to actually compile this, because right now, if I press run, it will not allow me to compile it. I get information that unreported exception, Java IO exception, must be caught or declared to be thrown. So in order to catch it, we're going to be using something that is called the try catch. So in order to catch an exception, we need to create a try block where we put the code that can result in an exception. For example, the create new file results in IO exception, as we can see here. Then I add catch clause, and here I point out which exception am I catching, and then I need to act accordingly. Something went wrong. So the way it works is that within the try block, the code will be executed, but if it happens to be throwing an exception, then all the changes that should happen within the try block will be rolled back, and then instead the catch block will execute. You can think of it as kind of an if-else situation. So if everything goes well, then of course we proceed, else we catch the exception and go forward. So try catch actually has another block to it called finally, meaning that this block will happen no matter what happened, I will execute. So the way it works is that whenever we have a try catch block, of course only one of them will be executed depending on what happens, and then finally will actually be executed each and every time, no matter which one has happened. So let's try it. Let's run this code. No matter what happened, I will execute. So it means that the try was created, we didn't get the IO exception, we didn't get the message that something went wrong, and finally, no matter what happened, our execute has happened. And here on the left hand side, you can see that the new file was created. So that's very useful. I'm gonna delete this now so that we can then reuse it. Do refactor, delete this, okay, thank you. So yeah, that's the try catch block. And very, very important, whenever there is an exception that is checked, so the easier one to handle, you will be forced to handle it. And what you see here is actually handling it. Because as you can see here, even though an exception can be thrown, the code will not stop working, will not get a stack trace. And in order to show you that, I'm going to input here null. Oh, it can't even work like this. So let's just use an empty path name. Yeah, and here you can see something went wrong, but still my program has executed properly because I have this catch clause that is not allowing me to actually fail if this IO exception occurs. Of course, there can be multiple exceptions and more than one that can happen, and they can be handled differently depending on what we want to give back to the end user. However, at this point in time, let's take them one at a time. So those are checked exceptions, meaning that we are forced to handle them. Now, let's try to create something for the unchecked exception. So if I also want to do this silly example that I had before, so let's say that I want to int double result equals 5 divided by 0. I can put it within, of course, this is a very, very silly example. I can just use try double result equals 5 divided by 0, catch arithmetic exception E, and printing out no dividing by 0. And let's try to run it. And here you can see there is no stack trace, there is no really issue that has happened. We get all the information from our catch clause, meaning that actually we have successfully caught the exception. So this is very, very important, because if you run into an exception within your application and you do not handle it properly, your entire application will break and it will cease to exist, meaning that you will have to rerun it. And this can be very, very problematic whenever we're talking about applications that should have a longer lifetime, right? Imagine you are working on your game, or rather you're playing your game, and then something breaks, there's an exception, it's not caught, and your game breaks. So this is also very common these days, but it's also very, very not nice whenever it happens. So make sure that you are also catching your exception whenever you get a chance to do so. So yeah, that's basically it about checked exceptions and unchecked exceptions. So let's take a look at how can we actually create an exception of our own. In order to do that, we need to create new Java class that is going to be called custom exception. And right now what I want to really do is, let's say we've got IO exception class, as we can remember, right? So I'm going to search for it, and what I'm going to do is take a look at it. Okay, it extends exception. So in order to create my own exception, what I know is that I will need to extend the same class. So in order to do that, let's extend exception. And what I want to do is, let's take a look at IO exception once again. I've got this thing for message, right? So what I can do here is write out my own message. So I can overwrite the exception message. So let's do this with get message, and let's just return custom message from exception. So now we've got our own custom exception. That's all nice, but then let's also make use of it, because in order to be able to use an exception, we need to throw it, and throwing an exception is happening within a particular method. So in order to showcase this, let's just create a class exception showcase, and what it's going to do is have a single method that is going to be used for throwing exception, throw exception, and here what it's going to do is throw new custom exception. And here I've got information that I'm going to explain to you in just a second. Why is it in red? But essentially, whenever you want to call an exception or make it happen and force the exception to happen, then you need to use the keyword throw. This is actually used to showcase that, yeah, this is the exception that's happening, this is the information that you should forward, and essentially this is the way to do it. So right now I've got two options. I can either handle this exception within this method, but this is not something that I want to do. I want to force every person that is using this throw exception method to handle it. And in order to do that, I can just use this throws custom exception. What exactly does it mean? What have I done? It means that each and every call of throw exception is going to be throwing potentially custom exceptions. So dear user of my API, you need to handle it. Essentially, this is forwarding the exception one level above without the need of handling it within this method. So within this throw exception method. So let's go back to main and let's just use exception showcase equals new exception showcase. And now if I go ahead and exception showcase that throw exception, I get information that of course it's in red, it needs handling. So I'm pressing Alt Enter, surround with try catch. And as you can see, right now what I'm going to do is I'm going to throw an exception and print out the message of the exception. Of course, exception is just a class, right? It's just an object of a class in this instance. So it means that I can use the methods of it. For this instance, I'm going to be getting the message of it and printing it out. So I'm handling this exception by printing out the message. So let's run it. And as you can see, I got custom message for exception. This is very, very useful within your own projects so that you can actually tell what is happening and give more information to the end user that something has went wrong. So to sum it up, whenever we're talking about exceptions, there are two main things for them. First of them is there are only checked and unchecked exceptions, meaning that those are the ones that we need to check on the compilation level or during the work of it. And the unchecked exceptions are way, way more dangerous. So that's the first thing. Second thing is to handle the exception. We've got two ways to do it. First of all, we can throw it up, meaning that the method that can throw the exception throws the exception in the method signature. Or we can use a try catch block, which actually means is try to execute the code that can result in an exception. And if it happens, catch it and do anything that I have written within this catch clause. Of course, I can also have a finally block that is going to execute no matter what happens. So this is very useful if you have an operation that you would like to do, no matter that there is an exception or not. So thank you very much for watching. In the next video, we are going to be talking about deep dive into the files. Once again, if you have more detailed question, would like to ask something, or just don't understand something from the video, go ahead and head on to the school group. I'm very active there. You can DM me directly and I will, of course, try and answer your questions to the best of my abilities. Thank you very much and see you in the next video.